Hello, everyone. Good evening. Welcome back to our English class. I hope everyone is doing well. And of course, I hope everyone is ready, all ready for this session tonight. Before that, let me just check if my presentation is all good and my audio especially. Okay, all good. Everything is good, the presentation as well as my audio. Let's immediately start with a continuation of our topic these days, which is on oil and gas vocabulary. Now, we established that we're going to talk about, especially this week, about this particular topic from the start since Monday. So, we're going to continue with that one because there are still some words, more words that were not included in the discussions last meeting. No, we tried to really divide all these essential terms, 25 essential terms, into three or more different sessions, so as to not overwhelm you, because these terms are not that much common, especially even if you are already an English speaker. um there are terms that are for professional use really, but it should be very helpful for you if you know it. Okay, so again, this is oil and gas vocabulary. All right, now we have here, before that, let's do a recapitulation or a review of our discussion last meeting. We've established that oil and gas are natural resources that take millions years to form. No, so these resources are buried miles underground. So when you try to discover them, you really need sophisticated technology, which is very important, and which are present in the existing world, no existing year, because of course we are more innovative these days, these years. So we can, there are technology, there are tools, advanced tools that we can use to really explore the Earth's crust and, of course, hidden reservoirs. So again, we've established there are three main sectors um, for getting the oil and gas, because doing it or doing so is really such a complex process. First, we have the upstream, which is on exploration, on production. So this is where the process begins. Of course, when you try to get something, you still try to look for it. No, where the location will, where will we be getting these particular natural resources? No, which location is the best? Something like that. So you try to find it first before you try to get it. After upstreaming, which is on exploration and production, we also have midstream, which is the transportation and storage. So you've already found it in the upstream, right? The raw oil and gas. So in the midstream, you already extracted it. So once it's extracted, of course, it should be transported. It should be stored properly, right? So that is midstream. And lastly, we have the downstream, which is on refining, on marketing. So that is the final stage of this complex process. Though there are only three processes or steps for this particular process, but these are all complicated and, of course, need a thorough attention to really get the finest of them all, no? Oil and gas. So, of course, when it comes to downstream, I've mentioned earlier it's on refining, no? Because by the time we extract the oil and gas in these natural resources from where it originally was in the Earth's crust, this is not yet ready to be used in a way, because this is what we call crude oil. It is raw, it is unprocessed oil. So we try to refine it. No, we clean it, we split it into various products, because oil and gas is not only for one use only. So we try to split it properly into what kind of use we're going to make it to do it. So, of course, this is where the final products are sold to businesses and consumers. So, those are the processes, those are the steps for this complex process. We have the upstream, midstream, and downstream. Okay, so in the past few days, we've already talked about these words. Let's just do a quick peek on these because, of course, you can just check the detailed explanation of these different terms in our past few videos. No, it's still there. Okay, let's start exploring. Again, we've already established or mentioned about barrel of oil and then followed by blowout preventer. Let's just do a quick definition of it. When we say barrel of oil, it is a standard unit of measurement. So barrel of oil is just basically it's not just a container. So it's more of a mathematical definition which we use to track the oil and gas. I'm sorry, oil and gas. No, so of course, the oil and gas are really measured in specific units so as to properly distribute it. Again, what was the standard? That is 42 US gallons or 159 liters. And then next to that, we have blowout preventer. When we say blowout preventer, this is a critical safety device. BOP. This is very large. This is specialized valve installed at the wellhead at the top. Okay, so it is more of like an ultimate safety switch for an energy wheel. So its primary job is to seal, to control, and to monitor oil and gas wells. No, so that we can prevent uncontrolled release of pressure, which is known as the blowout. And then next to that, we have the casing head gas. Now, the casing head gas are natural gas produced from an oil well. So, it exists as a gas that is dissolved in crude oil while it's deep underground under high pressure. Okay? So, it is really different from dry natural gas used to heat homes. It is often described as rich or wet because of its chemical makeup. Okay? So that's the casing head gas. And then next we have catalytic cracking. Now, when we say catalytic cracking, that is a high-tech refining process which is used to break down large, heavy hydrocarbon molecules into smaller, lighter, and more valuable products. Okay, so that is catalytic cracking. Next, we have directional drilling. Now, when we say directional drilling, that is from the name itself. Of course, we do drilling here. So the practice of drilling is non-vertical wells, which is unlike traditional methods that only go straight down. This technique involves intentionally going far from wellbore along a planned path just to reach the targets that are not directly below the surface location. So it's more flexible in that way. Okay, that is directional drilling. And then next to that, we have the drill bit. Now, when we say the drill bit, that is the cutting tool attached at the bottom of the drill string that breaks rock to create the well bore. Basically, when we say drill bit, that is it is like the tip of your drilling tool. Okay, so it's a specialized cutting tool attached to the bottom of the drill string, as mentioned here. Now, we've also established that there are three types of drill bits, right? So there are three types of drill bits. We have the roller cone bits, fixed cutter or PDC bits, and also the diamond bits. And of course, well, we've already talked about that in our past videos. So if you want to know more about this one, or if you want to be refreshed about what this one is, you can always look back at our previous videos, okay? Next is the drilling fluids. Now, drilling fluids are specially formulated liquids that are circulated through the drill string and wellbore during drilling operations. They are far more than complex than simple water because they are totally created, engineered mixtures of chemicals so as to, of course, to benefit. That is for use, of course, for efficiency boosting tasks, especially deep underground, which is, of course, our focus because that's where we get the oil and gas. So, yeah, that is on drilling fluids. This is for cooling, especially if the drilling tool is really drilling the rocks. So if you try to drill through thousands of feet of solid rock, it creates immense friction, which of course will heat the drilling tool. So it needs cooling, and the drilling fluid will cool the bit. Okay. And of course, it will also help lubricate so as to make it easier to really use the drilling tool. Okay. So next we have the engine oil. Now, engine oil, this is either petroleum derived or synthetic, which is used in internal combustion engines to reduce friction, cool components, and protect against wear. Um, well, that is how do you call that? Engine oil. It is more of how do you call that? Of course, that's the liquid that you're getting from all those steps that you are taking. Sorry, excuse me for that. Anyway, we're going to continue. Engine oil is um we see that how the oil and gas industry touches our daily lives, no? Because of course there are different ways we can use oil and gas. So it allows us to really learn how important engine oil is, especially in our daily lives, because once this particular economic product is touched, it will touch every other product. Okay, it will greatly influence because, of course, oil and especially gas is the main source of transportation. A truck or any kind of transportation vehicle cannot move without it, right? So of course, with that in mind, it will really be a very great impact to the lives of the people. So that is why we need to really know what engine oil is. It's a specialized lubricant, no? So whether it is in a car, a ship, or massive generators at maybe a train station, engine oil really performs several essential roles to keep equipment healthy. Like, for example, it reduces friction in cool components. It is a protective barrier that extends the life of the engine. Okay, for wearing, it prevents wearing, and of course, it is considered as advanced additives. That is engine oil. Next, we have full trap. Now, when we talk about full trap, it is a geological formation where a fault, which is, we call it the fracture or the crack in the Earth's crust, displaces rock layers. So this movement creates a physical barrier or a seal that traps oil and gas in a reservoir. So that is a fault trap, which is not especially safe. Okay. Next, we have the gas station. Oh, we already know this one. Gas station is a retail facility where motor vehicles are refueled with gasoline, diesel, or alternative fuels, also called a filling station, petrol station, or service station. Next, we have the gusher. Now, gusher, it is an uncontrolled release of crude oil of natural gas from oil after pressure is countered, causing oil to spray violently into the air. So this is what happens when the gas is not controlled properly. It gush basically, so it sprays violently into the air. No, it often reaches hundreds of feet above the drilling rig. So that is a gusher, a blowout basically. Okay, this is what the BOP is trying to prevent. No, a blowout because this is not safe. Next, we have the injection well. Now, an injection well, it is a well used to inject fluids such as water, gas, or chemicals into an underground formation for enhanced oil recovery or waste disposal. So that's what the definition is talking about. Now, unlike the traditional production well that brings a barrel of oil to the surface, an injection well works in reverse, pushing substances down into the earth. So it's more of like a dual purpose. These wells are used for enhanced oil recovery, or we call it EOR, or for the safe disposal of waste fluids. Okay. Next, we have the liquefied natural gas, or LNG. So that is a liquefied natural gas. So it is a natural gas that has been cooled to an extremely low temperature, usually negative 162 degrees Celsius or negative 260 degrees Fahrenheit. So this extreme cooling process changes the gas into a liquid state. So that is a liquefied natural gas. Because natural gas is usually just a gas, it is typically moved through pipelines. However, you can build a pipeline across an entire ocean. So this is where LNG technology becomes a vital service for global energy. Now, it enables transport across oceans by special tankers, so that is where you store this LNG or liquefied natural gas. Okay. Next, we also have natural gas. No, natural gas it is one of the most significant energy sources on the planet. No, it serves as a primary driver for heating, for electricity generation, for complex industrial processes. So, as a naturally occurring hydrocarbon gas mixture, it is a cornerstone of the global transition toward cleaner energy production. Natural gas is primarily composed of methane. No, it is typically making up 70 to 90% of the mixture. So that is a natural gas. And in its natural state, methane is completely odorless. Like it doesn't have any odor. And to ensure public safety, a specific chemical is added to the gas so humans can really detect leaks. Because if it is odorless, it is much more dangerous because we cannot detect if there are leaks that happening because of course we cannot smell it. So that is why for public safety, there is a specific chemical that is added for it to have an odor, no? So that we can detect it by smelling. And then we also have oil field, oil rig, oil well. Okay, we're going to continue. This is the last particular word that we've discussed last meeting, natural gas. So we're going to continue with another term, no? Another term, set of terms this evening. Before that, let me see if you are ready to a new session today. You can always use our chat box here. I will constantly check it. No, from time to time, I'm gonna check the chat box if there are any responses so that I can really accommodate to you. I can respond to you. May it be a question, a statement, or just a response, a reply from what I am saying. Okay, you can always use our chat box. Okay, so also before that, let's do a quick breathing exercise. So on my cue, inhale, exhale, inhale, exhale. Okay, we're good. For a moment, let me just check my audio. Okay, I think it's all good. Let me just talk for a moment because I feel like it's echoing. So let me just try to hear it again. Oh, that's all good. So let's continue. Let's start with another set of terms, starting with oil field. Oil field, as mentioned or defined here, is a geographic area containing one or more oil producing wells tapping into a proven underground petroleum reservoir. So that is an oil field. So oil field is a location basically. No, we've mentioned here it's an area containing one or more oil producing wells tapping to prevent underground. So it is the specific location where we can find the oil, no, from the name itself, oil field. So there is a process to really see how this oil field can be practiced, can be highlighted. So, same with the ones you mentioned earlier. There we have the upstream, the midstream, and the downstream. Okay. So this is, as mentioned here, there are key details. The largest is Gawar Field in Saudi Arabia, no, 75 billion barrels. It can span hundreds of square miles, contains wells, pipelines, processing facilities, and roads managed using reservoir and engineering techniques. Saudi Arabia's Gawar field alone has produced more oil than most countries have in total reserves. It's been producing since 1951 and still yields 3.8 million barrel per day. That's how massive the oil field is in there, not in Saudi Arabia. That is why that is really the main source, usually the main source for um, importing or exporting oil. No? Saudi Arabia. So again, oil field is the location where we can find stored oil. Okay? That is oil field. Next, we have oil rig. Now, oil rig is, as defined here, the complete set of equipment and structures used to drill a well, including the derrick, engines, mud system, and all associated machinery. So it is really an essential physical infrastructure used to drill a well and extract energy resources from deep within the earth's crust. Far from being just a single machine, an oil rig is a complex, complete set of equipment, structures, and even machinery designed to really operate in some of the most challenging environments on the planet. So, what is an oil rig? The term oil rig refers to the entire system used for drilling, which includes the iconic derrick or the tower, no powerful engines, a complex mad system, and all associated mechanical components. So, there are two main categories for this one. Rigs are generally classified as either land rigs or offshore rigs. So their operating hours, these are, of course, high intensity environments. So they usually, not usually, but they always operate 24/7 using 12-hour crew shifts just to ensure constant progress. And building and operating a rig is incredibly expensive. So that this is really a massive investment because as far as my research goes, a typical land rig can cost between 15 to 30 million dollars, while advanced deepwater offshore rigs can cost over 600 million dollars. That's a big difference, okay? Still, both are expensive, but of course, that is to be expected. Now, how do a rig operates? To successfully reach a fault trap again, the fault trap that is, um, how do we define a fault trap again? So this is where, how do you call that? This is where we can find us, because a fault trap is the first of harvesting energy. So fault trap, as defined in our previous sessions, that is where, sorry, I forgot. Let me just quickly check that I have fault trap. This is the fault trap. This is yeah, the fracture fault is the fracture. It displaces rock layers. It creates a seal that traps oil and gas. So basically, this is more of a fracture that seals, no? So it's more of like not really a safe thing. So that is a fault trap, no? Seal trap basically. Again, we go back to oil rig. So what is oil rig? Again, we've already mentioned about full trap, so let's go back to oil rig. So, oil rig, it should be able to successfully reach a full trap. Again, full trap is a fracture that seals the natural reservoir. And of course, an oil rig must manage several high-tech systems simultaneously. That is to be expected considering how expensive it is. So it can do drilling and steering. Modern rigs often use directional drilling. Again, directional drilling is it's where you are not limited to just to drill one location only, shut down. So you're flexible in drilling the particular Earth's crust. Okay, so modern rigs often use directional drilling just to steer the wellbore along a specific path. This allows the rig to reach targets miles away from its physical location. And the rig's mud system, it circulates specially formulated drilling fluids. This mud is vital for cooling the drill bit and maintaining wellbore pressure to prevent the well from caving in. So there's also pressure management after the drilling and all the steering. And then, of course, every rig is equipped with a BOP. Again, what's BOP? That's blowout preventer. It is a critical safety device, which is placed at the top in case there's a blowout or an uncontrolled pressure. Okay, so this massive valve can seal the well in under 30 seconds to prevent an uncontrolled release or the blowout, which is also known as the gusher. Okay, so of course, safety first is our priority. Safety is our priority. And we've already talked about offshore rigs, right? Now, when we talk about offshore rigs, it represents some of the greatest engineering feats in history because it is really designed to withstand hurricane force winds and freezing temperatures. Say, for example, in Berkut, the world's largest offshore rig, which is located in Russia, weighs over 200,000 tons. To put its size in perspective, it is heavier than the Golden Gate Bridge. That's how heavy it is. No? And then, of course, we've also mentioned that there's like deep water, no, in rig, which is much more expensive because it is more challenging. These rigs must maintain stability while drilling through thousands of feet of water and then thousands more feet of rock to harvest every barrel of oil. Okay, so the work performed of an oil rig is the first step in the chain that powers our modern world. We do collection, we do refining, we do distribution, we do natural gas. So collection, once the rig is successfully taps into an oil field, the raw crude is measured and eventually sent for refining. And then when we say refining, the crude is transformed through processes, say for example, the catalytic cracking, which turns into fuels like gasoline or diesel. And then there's also distribution because these products will eventually reach your local gas station or provide the engine oil that keeps your car running. And of course, natural gas rigs also capture casing head gas, which can be processed into energy for homes or cooled into LNG, like liquefied natural gas, for global transport. Okay, that is oil rig. Next, we have oil well. Now, an oil well is a boring or hole drilled into the earth to extract crude oil and petroleum gases from underground reservoirs. An oil well is a fundamental access point for the world's energy supply because it bridges the gap between the vast geological formations and the technology that is used to harvest them. No, because if you like think about the anatomy and construction of a well, drilling an oil well is a massive engineering undertaking, which means that it really requires precision and specialized materials to handle intense pressure and heat. No, so the boring and the depth of this is that a typical well has an average depth of 5,000 to 15,000 feet. For perspective, the world's deepest well, the Z44 Chaivo in Russia, reaches a staggering 40,604 feet, which is deeper than the Mount Everest is tall. So it's taller than the Mount Everest, no? So that's how deep it is. And then after the boring, no, after making it deeper, we case it, we cement it. So to ensure that the well does not cave in and to protect the groundwater, the hole is lined with steel casing and then cemented into place. And of course, lastly, the rig. The construction of the well is managed by an oil rig, which houses the engines, the derrick, the complex mud system required for drilling. That is why an oil rig is very expensive. Okay? It's very expensive overall. No, I've already mentioned how much it typically asks for. So once the boring reaches its target, such as underground full trap, the extraction process begins. Methods of production, the well itself, it produces resources using natural pressure. So mechanical pumps, they can also do artificial lift techniques. So those are just different methods of production. We also have the directional drilling. Again, this is um, to intentionally go away from well bore, which allows them to reach reservoirs miles away from the surface location or even drill horizontally because modern wells are not always straight vertical lines. So it's much more flexible. And then throughout the drilling process, mud or drilling fluids are circulated to cool the drill bit, no? Because again, there's friction, especially if there's too many rocks. And then it also carry rock cuttings to the surface and maintain well bore pressure to prevent accidents. No, which is of course our priorities to the safety. And because we're already talking about safety, no? I'll also include environmental control because wells tap into highly pressurized environments. So safety equipment is really essential to prevent a gusher or a blowout. Now again, BOPs, every well is equipped with that. No, blowout preventer, a massive 400-ton valve that can seal the well in under 30 seconds, especially if sensors detect a sudden surge in pressure. No, that is a critical safety device. And then we try to monitor the pressure because, of course, we don't want it to be not controlled. If the pressure is not managed, an uncontrolled release or a blowout can occur. So we really do, or they really do monitoring of the pressure. No, so that is pressure monitoring because pressure blowout are really intense. No, it's not just one time thing. It's really intense. It's similar to the famous spindle tap gusher that shot like 100,000 barrels per day into the air in 1901. Okay. And then we'll also have casing head gas, so dissolved gas that is released at the surface as pressure decreases is known as the casing head gas. We already know that. So while once burned off as waste, it is now captured as a valuable resource worth billions annually. So a single well is usually part of a larger oil field, which is a geographic area containing multiple wells tapping into proven petroleum reservoir. Oil fields can span hundreds of square miles and include complex network of pipelines and processing facilities. Sorry. No. So an oil field is the particular location. Oil well is just part of it. No, that is where we can find the multiple amounts of oil well. So the raw crude and natural gas extracted from the well undergo extensive processing before reaching the consumer. Okay? No, extensive refining. So that is oil well. Next, we have the petrol. A petrol, as mentioned here, a volatile, flammable liquid hydrocarbon fuel refined from crude oil, used primarily to power internal combustion engines called gasoline in North America. It basically serves as the primary energy source for internal combustion engines worldwide, which was mentioned here. It powers everything from personal vehicles to industrial equipment. So petrol is a complex mixture of relatively like light hydrocarbons, because the name itself has deep historical roots originating from the medieval Latin petroleum, where petra means rock and oleo means oil. So there's still refinement process where petrol is produced during the refining of crude oil. There's boiling range even. It typically has a boiling range between 30 degrees Celsius and 200 degrees Celsius. And then the quality and performance of petrol are measured by what we call octane ratings, which generally ranges from 87. 87 is the regular one, and then 93 is the premium one. So 87 to 93 is the range. And aside from that, modern petrol contains various additives, which is designed to improve engine cleanliness and overall performance. So the journey of the petrol begins deep underground, no? Still the same process because we're talking about oil and gas. So it is often in geological formations like a fault trap. Once the crude oil is extracted by an oil rig, it is sent to a refinery. No? One standard barrel of oil is how many? 42 US gallons, 159 liters, which produces approximately 19 gallons of gasoline. So that is just to really see the how do you call it, to really see like the barrel of oil can produce 19 gallons of gasoline, not to compare. And then to increase the high yield of value fuels, refiners use catalytic cracking. No, we use heat, we use zeolite catalyst to break down heavy large hydrocarbon molecules into the lighter molecules found in petrol. Catalytic cracking is really a vital service to the industry. No, it produces about 50% of all gasolines in the United States. So that is petrol. Ah, yeah, I also forgot, of course, there's distribution and infrastructure. Once that petrol is refined, it is transported to a massive network of retail facilities known as the gas stations. No, the retail scale is usually there are over 150,000 gas stations in the United States alone. So that is like the scale of it. That's already a lot. No, so these facilities use underground storage tanks that can hold between 20,000 and 40,000 gallons of fuel. So of course the oil and gas can be found underground. Okay, that is where the storage of the oil and gas is. And because we're also going to talk about safety and management, because petrol is highly flammable. So the entire supply chain from the oil field to the pump is strictly managed for safety, because we don't know what will happen, since again petrol is highly flammable. So during extraction, the BOP is really used to prevent an uncontrolled release or gusher of crude oil and gas. And then of course in the vehicle, petrol works alongside engine oil, which reduces friction, and it protects the engine components from the heat and water caused by combustion, and of course pressure stability. DF, or drilling fluids, which is the MAD, are used during the initial drilling of wells to maintain well bore pressure and prevent accidents, or friction. So that is um petrol. And petrol is just really one part of the global hydrocarbon landscape. We also have natural gas, which is again the very example is casing head gas. This is usually used for heating and electricity. We also have LNG, liquefied natural gas, for global transport. And then environmental efforts here is that technologies like we mentioned about injection wells, they are now used for carbon storage to really help offset the environmental impact for of fossil fuel use. Okay, that is petrol. Next, we have the pipeline. Are we going to continue? So far, we've already talked about oil field, again, the area, the large area, oil rig, oil well, petrol, and petrol. So how many? One, two, three, four. Let's continue with pipeline, and then we'll do a break after, because again, the terms are really overwhelming if you're not familiar with these ones. So if you do not interact with these ones, it's very overwhelming in a sense. So we try to really do breaks in between, so that you're still, no, your brain is still ready to absorb everything, especially if properly rested. Anyway, we're going to continue with pipeline. Pipeline, as defined here, is a system of pipes used to transport crude oil, natural gas, and refined products over long distances from the production sites to refineries, storage, and distribution points. Basically, these networks are, or this network, the pipelines serve as the circulatory system of the global energy industry, because it connect production sites like an oil field to refineries, no, what other else, storage hubs, and of course, final distribution points. The scale of modern pipeline infrastructure is really staggering in a way that it requires advanced engineering just to cross deserts, mountains, urban environments even. So there is a massive network of it. The United States alone contains over 2.6 million miles of pipelines. That is totally large, no? Large scale transmission pipelines can reach up to 48 inches in diameter. So that's the pipe dimensions. And the flow speeds, liquids and gases move at different rates. Usually oil typically flows at 3 to 8 meters per hour. And then while natural gas moves much faster at 15 to 25 mph. Pipelines are the primary method for moving various hydrocarbon products from the wellhead to the consumer. So, transported from instruction sites to refineries are the crude oil. It is where it is measured by the barrel of oil or 42 gallons. And then it moves through specialized network to power homes and industry. That is the natural gas, again, the LNG. And after processes like catalytic cracking, um, the pipelines that carry petrol or gasoline to regional storage centers, they do that and then eventually to a local gas station. And still, safety, monitoring, maintenance, all those things, management. We've established already that they carry flammable materials. So pipelines are subject to constant surveillance and rigorous safety protocols just to avoid any kind of incident. Okay, that is pipeline. Any questions so far? Let me check the chat box. No, I would definitely be happy if you have any questions because again, these terms are very complex, no complicated, even if you're not really exposed to these terms. So we try to make it slow. No, we try to really keep up with the pace of all. So again, I mentioned earlier we're going to have a break. Let's be back by 6:45. Okay? Goodbye everyone. Goodbye. I'm not leaving yet, okay? We're just going to take a rest. No, it's already 6:42, so we're going to be back by 6:47. Not a 5-minute break. Drink your water, do biological breaks, and etc. Rest well, and then be back by 6:47. Okay? I'm gonna turn off my camera and mic. Hello everyone. Welcome back. I hope you all properly rested. No, though the break is short, it's only 5 minutes, but I hope you had your water already. No, you quenched your thirst, you do your biological break, and properly rested for 5 minutes. Anyway, we're going to continue with another set with the remaining terms. Let's do first a quick breathing exercise to properly, be back with the lesson. On my cue, inhale, exhale. Again, inhale, exhale. Okay, let's move to the next word or next term. Yeah, this one, pipeline. Okay, that is the next term. Now, what is a pipeline? A pipeline, as defined here, is a system of pipes used to transport crude oil, natural gas, and refined products over long distances from production sites to refineries, storage, and distribution points. A pipeline, it is also more of like a circulatory system of the global energy industry because if you think about it, a pipeline is a really vital service because modern life would be significantly disrupted if there is no pipeline. They provide a lively atmosphere, especially for our cities, by ensuring that energy is always available for heating, energy is always available for transportation, and for even electricity. So when it comes to efficiency, they are generally considered the safest. They are considered the most efficient way to move large volumes of energy compared to trucks or trains. Now, when it comes to efficiency, to longevity, with proper maintenance using engine oil so that it will not wear easily, um, especially for pump station machinery and regular pigging. These particular assets can operate for decades, no? The pipelines. So yeah, we do that, no? Pipelines. Again, pipelines is very important. It mentions here it's used to transport crude oil. Okay? We've already talked about how a pipeline is usually is no it's again it is where the petrol, the gas, the oil is going to travel. And US here, there are key details. US has over 2.6 million miles of pipelines. That's very long. Large pipelines can be 48 inches in diameter. Oil flows at 3 to 8 meter per hour, or gas at 15 to 25 meter per hour. And then it is monitored by SCADA systems and smart pegs. Okay. Okay. So this is again pipeline. Smart pegs is the pipeline inspection devices. It travel inside pipelines using sensors to detect corrosion, to detect cracks, because of course it is not safe for the person to go inside the pipeline. They are called pegs because the early versions squealed as they moved through pipes. So there will always be a reason as to why that happened. Okay. Now the SCADA system here is the modern networks that are monitored, not modern networks, but the system that detect pressure changes or leaks in real time. Same with smart pegs. SCADA is an abbreviation for an acronym for supervisory control and data acquisition, which used to monitor um, these pipelines 24/7. So smart pigs again, these are high tech inspection devices that travel inside the pipes using sensors just to detect any cracks or corrosion. Okay? So just as blowout preventer or BOPS manages pressure at the wellhead to prevent a gusher, pipeline stations use valves to maintain safe flow pressures, no? To control the pressure because again, it will be very unfortunate if the pressure is not controlled. That is a pipeline. And pipeline is not a standalone, meaning it does not act alone. No, pipelines does not act alone. They are integrated with other drilling and recovery technologies. So we do extraction, we do collection. There are also support system, and then of course environmental management, because we always try to really we always do our best to not harm the environment, because we're getting the oil and gas there, no, in the environment. So we should not be able to harm it that really bad. Okay, so there's always environmental management. Again, that is pipelines. Next, we have the platform. Platform, as defined here, it is a large offshore structure from which wells are drilled, produced, and maintained. Serves as a base for drilling production and crew accommodation at sea. So, an offshore platform, it is massive. It is a really complex structure that is designed for the drilling, for the production, for the maintenance of oil and gas wells at sea. These engineering marvels serve as a primary base for operations. So it provides power, it provides storage, accommodation for crews working in some of the most isolated and busy environments on Earth. So the design of platform is primarily determined by the depth of the water and the specific needs of the oil field. There are fixed platforms, so these structures are anchored directly to the seabed with steel or concrete legs. They are incredibly stable but are generally limited to shallow waters or shallower waters. There's also jack up rigs. These are mobile platforms with long legs that can be lowered to the seafloor, jacking the hull above the water level. There's also floating and semi-submersible. For deeper waters, platforms are designed to float. So semi-submersibles use large submerged pontoons to really maintain stability even in rough seas. And then deep water capabilities. Modern deep water platforms can operate in depths exceeding 5,000 feet. For example, the Perdedo platform in the Gulf of Mexico, it operates in 8,000 feet of water, which is a depth so great that if the Burj Khalifa were placed on the seafloor, the platform would still be 5,000 feet above its tip. That's how deep it is. Now, a platform is more than just a place to stand. It is a complete set of high-tech machinery integrated with an oil rig. So there's really drilling and production. No, that's the operational hub. There's of course first the pressure management. Drilling during drilling, the platform crew manages the drilling fluids, not the mud, no, the richer wet one. That just to maintain the wellbore pressure and cool the bit, because again the bit is prone to friction or heating, so we use drilling fluids to cool it down. And of course safety is always critical. No, every platform is equipped with a BOP or blowout preventer at the wellhead. This massive safety valve is really designed to prevent an uncontrolled release or gusher, which could lead to environmental disasters at sea. No, not very environmentally friendly if that happens. And then we also have advanced steering. So the steering is the directional drilling. No, crews use directional drilling to reach multiple reservoirs from a single platform. It sometimes extend wellbores miles away from the structure's location. Okay? And then, because platforms are often located far from shore, they must be entirely self-sufficient. No? They provide a vital service to the people living there. So life on a floating city, crew capacity is usually 100 and 200 workers. A single large platform can house those many of workers, 100 to 200 workers. These structures include living quarters, no, the facilities basically, Inside the large platform, it has the living quarters for the workers. It has kitchens, no medical clinics, which is very important, and helipads for crew transport. So they use helicopters, no, for transporting, may it be the product or the crew. And then like land-based rigs, it still operate. No, the platform still operates 24/7 with crews typically working 12-hour shifts. So that's a continuous operation, no? And then the engineering here, of course, well, based from what you've heard about the platform, the engineering really required to build a platform that can survive any kind of calamity, especially hurricane force winds and saltwater corrosion, which is immensely expensive. So expected that there is a high cost in building, in installing a modern offshore platform. It can cost really between $1 billion to $8 billion. That's how expensive it is, no? But if you just think about it, it's a great investment. No, it's also great economic impact. So yeah, if you have the money, you can always do that. Okay. Production scale. Well, expect that the production scale is really massive, considering how expensive the how high the cost is, as mentioned earlier. So once these platforms are operational, these structures process massive volumes of crude oil. It is measured again by the barrel of oil, which is how many gallons? 42 US gallons or 159 liters. And then, of course, we process it. Natural gas produced on site, known as the casing head gas. It is collected and processed for transport via pipeline or cooled into liquefied natural gas or LNG. So the platform really represents the pinnacle of industrial engineering. It is a complete set of infrastructure that allows humans to harvest energy for the most remote places on the planet. No, platforms often use injection wells to pump water or gas back into the reservoir, which can help recover 30 to 60% of oil. Okay. And then, of course, that's the recovery efficiency. So the resources harvested here is eventually will undergo catalytic cracking just to produce the petrol used at your local gas station. No, that's the refining journey. Okay, and that is platform. This will be our last term for the day. So far during this session, we've talked about first oil field, oil rig, oil well, petrol, and pipeline, and platform. So there are six complicated terms. Though the terms are usually simple, no, the words used are simple and easy to understand as common word. But if you try to connect it with oil and gas vocabulary, it really is complex. Okay, so there are still remaining words left here. We're going to continue with our last discussion tomorrow. Okay, any questions, everyone? Let me see the comment section. I guess none. Well, that will be all for this session. Goodbye and have a great rest of the evening. Goodbye and good night, everyone.